We're going to talk about end behavior today. And end behavior is really just what the equation is doing at the ends, meaning like the left and the right hand side. So I've got a couple of examples here we're going to look at, and I'll show you what you need to look at on the graph and in the equation to figure out what the end behavior is. So there's two different types of exponents that we can encounter. And we're looking at the highest degree term here. So if it's in standard form, it'd be the first one. So you can either have an even exponent or odd. So this would be an example of an even because it's x squared. And then we're also going to look at the leading coefficient here. We're going to look at the number on that term. It can either be positive or negative, and that can happen in any kind of possibility, four different possibilities. So it's not always even and positive or odd and negative when I write it like this, is what I'm trying to say. All right, so if you look at this first example, just looking at the equation, not even looking at the graph, we see that we've got a even exponent. So I would call this an even. And then the leading coefficient is positive. So this is called a function that's got even positive end behavior. So when you did graph it, this is the example of what the graph looks like. So what that means is that on the ends of this graph, on the far left and on the far right, that we're increasing on both sides of that graph. So that's positive on both sides. And even graphs always have the same behavior on the left and the right hand side. So if it's even positive, both on the left and right is going to be pointing up. All right, let's go to the next one. All right, so first thing we're going to do is we're going to figure out what the degree is. So the degree looks like it's going to be 3, so that's odd. So I'm looking at that term. So that's odd. All right, now what about the leading coefficient on that term? It's still a 1, and it's positive. So that's what we call an odd positive end behavior. All right, so now look over here at the graph, and you'll see that on the far left, if you go the furthest left point on this graph, it's going down, and the furthest right part is going up. So if we look at it from left to right, the left-hand side looks like it's going down, negative direction, and then on the right-hand side, it's rising up in a positive direction. So on odd degree functions, the graph is always going to have this kind of shape. You know, one side's going to be rising and the other side's going to be falling. It's going to be going in the negative direction, and one side's going to be going in the positive direction. So if it's odd positive, the ends of the graph, no matter what that exponent is, if it's 5, 7, 9, whatever, and the leading coefficient is a positive number, it will have this shape. Okay, so here's another one. All right, so we're looking at the highlighted term again because it's the one that's got the highest degree. So this one is x squared. That's also even. The negative on the leading coefficient this time, it's a -1. So that is going to be negative. So this function has what we call even negative end behavior. Okay, so look at the graph. This is the actual graph of the function. The arrows are both going down because on the left side of this graph, it is going negative, negative, negative. Right-hand side still going negative, negative, negative. So for even negative functions, the end behavior will always have that end behavior. All right, one more. So I've seen 3 of the cases. This is the last one. Okay, so here we go. We've got an odd degree, and it's 3. So that's odd. And then we've got a -1 leading coefficient. So that is negative. So this is the last possible combination. It's odd, negative, all right? So again, we said in odd functions, the end behavior, one side's going to be rising in a positive direction, the other side's going to be falling in a negative direction. And so on this one, we're rising on the left, falling on the right. And again, it doesn't matter what the exponent is. If it's odd, And if that leading coefficient is negative, it's going to have this shape on the ends of that graph, okay? So what we need to do is let's just make a little summary of the different kinds of graphs and what the end behavior is going to be for those depending on what the degree is and all that good stuff, all right? So here's what I usually will do. I'm so sorry, that is a horrible line. I will usually make a little grid here and write down all the possibilities. So odd positive, odd negative, even positive, and even negative. So why are we been talking about this? Well, we need to talk about this because what we're going to do after we talk about end behavior is to go back to the functions that we're finding the zeros of and try to sketch what a graph would look like. So we're going to put all this stuff together. All right, so for odd, positive, odds go in opposite directions. But if it's positive, it rises on the right, falls on the left. All right, now odds, again, go opposite directions. But if it's odd negative, it's going to rise on the left and fall on the right. Okay, so the general shape of the graph on the ends, just like we talked about, that's what it's going to look like. Now for evens, evens go the same direction on both sides. If it's even positive, both ends will be rising to the right. If it's even negative, both ends will be falling on the left and right. So somebody has pointed this out, and it's a good thing to kind of show you. If you look at the arrow on the right, it tells you positive or negative, okay? No matter if it's odd or even, if it's rising on the right, it's positive. If it's odd or even, no matter which one, if it's falling on the right hand side, it's negative. And that is very helpful. So if you think about it in terms of the y-axis, this is positive, this is negative. That gives you the leading coefficient part. And then you've just got to know if it's opposite sides. If it's rising on the other side, then it's an odd. But if it's the same direction on both sides, it's an even function, all right? So let's just see what that would look like if we were looking at some pictures, how we would decide what the end behavior was, all right? So I can give you an equation or I can give you a graph. So if I give you a graph, all you have to lean on are the directions you can see on the left and the right. So let's just go ahead and put arrows on there and let's think about which one this is going to have to be. Now, based on the way it's set up, these are going in opposite directions. So odd is opposite direction. So I know it's an odd exponent. I know the degree is odd. It's probably like an x to the third or an x to the fifth equation. Now, because they're going opposite directions, again, it's odd. The question is it a positive or a negative odd function? Well, if you look at the arrow on the right, it tells you which one it is. This arrow is going up. So when you think up, you think positive. So this is an odd positive. I don't know what the equation is, but it really doesn't matter. I can figure out the end behavior based on that. All right, so here's another one. All right, so both ends are pointing up. In that case, we know it's even. All right, so look at the arrow on the right. It tells you positive or negative. It's positive. It's going up. So that's an even positive. And you can use these abbreviations. It's fine. All right, last one. So see how every time I'm doing one of these, I make arrows that kind of box it off so we can see what's just happening on there. I don't care what's happening up here, or even in between on these. That part is irrelevant for what I'm trying to figure out. Now, if I needed to know like x-intercepts or something, I would worry about that, but I don't need to know that. I'm just trying to figure out end behavior. All right, so they're going the same direction. So what does that mean? It means even. And they're both pointing down, but if I look at the arrow on the right, it tells me it's negative because that is a negative direction.